What's going on, guys? Let's do this problem right here. This question is asking find the radius and intervals of convergence of this summation x plus 2 power n over n plus 3. Let's see how we can do this. So first thing we have to do is we have to find out the intervals of convergence. So to find the intervals of convergence, first thing we have to find endpoints, right? To find the endpoints, what we do is we take the ratio test for this one. Ratio test is limit n approaches infinity an plus 1 over an in the absolute value. So here we are going to have limit n approaches infinity, and then an plus 1 is going to be wherever we have n, we just going to add 1 to that. So here we are going to have x plus 2 power n plus 1 over n plus 3 plus 1, so that's going to become n plus 4. So here we are going to have n plus 4, and then we have to multiply by, we have to divide by an. An is this original function, and dividing by this one is same as multiplying by reciprocal of it. So here we are going to have n plus 3 over x plus 2n, right? So this is going to be the multiplication, and from this one we can notice we can cancel this one because this is same as x plus 2 power n multiplied by x plus 2 power 1. So if we cancel, x plus 2 power 1 will remain, right? So here we are going to have x plus 1 power 1, x plus 2 power 1, and then we have these things. Now let's rearrange this one. We are going to have limit n approaches infinity. So here we are going to have x plus 2 power 1 times, so let's put 1 over here, and n plus 3 n plus 4, right? Since we are applying limit for only n values, right, so we can take this x plus 2 outside. So let's go ahead and do this. If we take x plus 2 outside, this is going to be limit n approaches infinity n plus 3 over n plus 4. Now if you notice that power, we have same power in the n power 1, n power 1, so the ratio is going to be the limit. So this is 1 over 1, that's going to be just 1, and here this is absolute value, and x plus 2 absolute value times 1, right? This is what we are going to have after we take the limit. Now this one is less than 1, so whatever the value we found out from ratio test, we have to make it less than, that's going to be less than 1. So that's the main thing in power series kind of thing. So here this is going to be x plus 2 is going to be less than 1, right? Now what we have to do, if we take the absolute value out, this is going to be greater than -1 and less than 1. This is the value between. Now what we do, we take this 2 outside. So if I take this one outside, 1 minus 2, that's going to be -1. And here if I take this one out, this is going to be -1 minus 2, that's going to be -3. Now this is our endpoints. Now we have to check whether these endpoints converges or diverges. To find that one out, what we do, we plug these endpoints in the original equation, that is this one, and find out whether that series converges or diverges. So first of all, let's do it for -3. So we are going to have summation n is equal to 0 to infinity, and then we are going to have -3 plus 2. -3 plus 2 is going to be -1, right? -1 power n over n plus 3. And if you notice, this is alternating series. So whenever we have alternating series, to find whether it converges, what we do is we take the limit, and it has to be equal to 0, and the function has to be decreasing. If one of them fails, that means that this series diverges. Let's check that one. whether that series converges or diverges. Now limit n approaches infinity. So for alternating series, we only take bn value. Bn value means everything except -1. So if we avoid -1, we are going to have 1 over n plus 3. So 1 over n plus 3, and you can see 1 over infinity, this is definitely equal to 0. So this one converges, this one is limit is 0. Now it has to satisfy another test to see whether it converges, right? That means the next test is we have to find out whether this series is decreasing, and you can plug some values and check it, right? For example, so we only check for bn value, and if you plug 0, this is going to be 1 over 3, and then if you plug 1, this is going to be 1 over 4, and then if you plug 2, this is going to be 1 over 5. And you can see as the number increases, this value become less and less because we are dividing by higher numbers, so the total value is going to decrease. So this is a decreasing. Limit is 0, decreasing, so this one converges. So this is going to be included in our intervals of convergence. So when we write the intervals of convergence, what we do, we put -3 in square close bracket, right? Close bracket. Now we have to find whether this -1 converges or diverges. To find that, we again go ahead and plug for x value. So this is -1 plus 2, you can see that's going to be 1, right? 1 power n. 1 power anything is going to be 1. So you can just write sigma n plus 3 to infinity 1 over n plus 3. And if you notice, this is the p series, right? You can take this value 1 over n alone and check. You can see this one is a divergent p series because we have power 1. So divergent p series. Now you may think about direct comparison test. If it's divergent, you have to show this value is greater than this, but in this case this is lesser than this because this n plus 3 is bigger than n, right? So if you divide this one by this is definitely smaller than this. So you can do the direct comparison. So in this case, you have to do the limit comparison test. So limit comparison test says that if you divide this one by this one, and if you get a positive finite number, that means both of them behave in the same way. So let's go ahead and check whether we are getting a positive finite number. So let's do the limit comparison test. Limit n approaches infinity, and then we are going to have 1 over n plus 3, and we have to divide this one by 1 over n. That is same as multiplying by flip of this. That's going to be n over 1. And if you notice, this is going to be n. Both of them have numerator and denominator have same power. To make it clear, we can write it like this. Limit n approaches infinity, n over n plus 3, right? Numerator and denominator have same n power 1, n power 1. So the ratio is going to be the limit. So here the limit is going to be 1. So this one also, so this is positive finite number. So this means whenever we have positive finite number, this one behaves as this one. So this one is divergent. So this also divergent. So what's going to happen is when we write this one right here, this is not going to be included. Like we are going to put open bracket. So that is going to be the final answer, and they're asking intervals of convergence and radius of convergence. To find the radius of convergence, what we do, we just take these two endpoints, -1, -3 divided by 2, right? We just subtract and divide by 2, and that's going to give us 1, and that's going to be the radius of convergence. And that's it. I hope you guys find this video helpful. See you next time.